All right, it's 12 o'clock, and thank you very much for joining us. Good afternoon, and welcome to Georgia DNR's Lunch and Learn series. I'm Emily Wingo of the Georgia Department of Natural Resources, Floodplain Unit. First, a little housekeeping. We are in listen-only mode, so please make sure your mic is muted. If you're having Wi-Fi issues, you may want to turn off your camera and any other programs you may have running. Please make note of the chat feature in your screen. Use the chat for communication, as we will not be taking questions by audio. Aaron Kyle of Dewberry is monitoring the chat and will try to help you with technical matters. We are offering 1 hour of continuing education credit for CFMs. To receive the credit, you must be logged in separately, answer all poll questions during the session, and provide your name and email at the end of the presentation. Please use the radio buttons to respond to the poll questions in either the pop-up window or in the chat box. A copy of the presentation will be emailed to all attendees. Also, a survey link will be provided at the end of the presentation. We appreciate you completing the survey so that we may improve these webinars in the future. We are recording today's webinar and plan to post the video to on georgiadberm.com. With that, let's get started. Today's presentation is Best Practices in Floodplain Management, Community Success Stories. Our presenters are Kevin Osby, Dr. Rob Brown, and Donovan Cushney. Kevin Osby currently serves as the Stormwater Program Director for the Clayton County Water Authority. He's held the position since 2006 when the authority's stormwater utility was formed. Mr. Osby has also been employed with the authority since 2004. Prior to the authority, Mr. Osby served in a variety of roles with CH2M Hill Atlanta in construction management and the Environmental Business Group. Mr. Osby is a graduate of California State University Northridge and has a Bachelor of Science in Mechanical Engineering. Mr. Osby is also a certified floodplain manager. Dr. Rob Brown is a senior water resources engineer for Goodwin Mills in Kaywood in Brunswick, Georgia. He has extensive experience in monitoring, researching, and designing green infrastructure practices. Rob earned his PhD from NC State University and completed a postdoctoral research fellowship with the USA EPA's Office of Research and Development, both focused on green infrastructure stormwater management practices. And Donovan Cushney is currently the floodplain coordinator for DeKalb County. Mr. Cushney has been with the county for 19 years, providing engineering plan review and floodplain management, with roughly 6 years in floodplain management. He formerly worked in civil, environmental, and geotechnical engineering consultancy. He is also honorably discharged from the U.S. Air Force. Thank you, gentlemen. And with that, let Kevin get started with us.
All right. Good afternoon, everybody. Thanks for the opportunity to discuss one of our projects that's currently in design right now. Project is located at the confluences of Camp Creek Tributary 5 and Tributaries 5C. That's up in the northwest corner of Clayton County. We are right on this location is right on the border with the city of South Fulton. Next slide. So we had been engaged with several residents over in this area. They had noticed just a lot of extra flooding. The community that I'm talking about is, if you look at the slide, you'll see Camp Creek Tributary 5C. You'll see the 0.2% chance, that sort of salmon colored area there. These residents are on the north side of that. You may see a street called Allen Court, just to the north. We have been in communication with several residents over here because they had observed just increased flooding from smaller events, storms. They knew that with the creek behind them and the creek over to the east of them, they knew that during really heavy rainfall events, they would see flooding, but they started seeing more and more sort of nuisance flooding at lower event storms. We initially went over there 2009. We noticed the flooding source, which was from Tributary 5C at the time. Smaller event storms. One thing we found out was they started noticing some of this creek migration if you want to call it that, once another subdivision was built directly to the south of them. They noticed that when that development started, they noticed, a little more material being sort of migrated, which sort of pushed the creek a little closer to their houses, and to the point where we had a real heavy storm event back August the 30th, 2020. Several of those yards were flooded. The homes were not impacted, but uh, the flooding around their houses were really bad. Um, you know, we tried to go out there, and unfortunately, a lot of the area is all private property, is off the right of way, and there's really nothing that we can do. But that event on August the 30th of 2020, uh, we had flooding all around the county, and one of the commissioners convened several of departments in the county, including the water authority, but we also had EMA and transportation and development, building building permit department. We had a lot of folks out there, and the commissioners wanted to see if there's something that could be done. So at that point, we worked with one of our small engineering firms, R2T, engaged with them to do sort of a concept study to see what we can do to, if there are any options available to make some improvements over there. And that work was done by them. Um, and next slide, please. So that work was done, and we looked at ways of possibly in introducing some sort of wetlands and tributary system over there, to where we can do some grading in that area, improve the amount of drainage or runoff that's going into the residents' yards over there, and trying to direct that drainage from tributary 5C to a wetland feature. And this picture that you see is a concept design uh, that um, that we looked at initially. Obviously, we've gone through several more iterations of that uh, to move forward, and we realize that, hey, there is something that we can do here. So let's move beyond the concept design. But we really only wanted to address those lower intensity storms, minimize any yard flooding to those neighbors. Perform that site grading. There are a couple of vacant properties at the end of Judy Lane there that we might be able to use those entire properties. We went ahead and determined that, hey, we need to go ahead and move forward in the actual design. Mind you, these are still private properties, but our friends at the county, they were able to get some CDBG funds to sort of help with that process. And we use some watershed funding to help pay for that. The full scale design, permitting and bid services by RTT was estimated at about $257,000. We estimate construction to be about $1.1 million. And as I mentioned before, we're going to use a combination of CDBG grant funding that the county had, and some monies from our stormwater watershed budget. Next slide. So the scope of services that we use for R2T for their actual design services were essentially six tasks. Obviously, you do that boundary survey and tree inventory. You do all of your H&H stormwater analysis. Task 3 was to perform preliminary engineering, then go into detailed design, permitting, and move forward on with bidding support activities for the overall scope. Next slide, please. So CCWA, we realized that most of this work would have to take place on those two vacant parcels. One, we found out, was actually acquired by the Clayton County Land Bank. That's the property on the west side of the road. And on the east side of the road, there was a private property owner up in New York who purchased that. Obviously, both of these are in floodplains, so we were able to acquire the one property from the land bank. We worked with them, and then we reached out to the owner for the other property on the east side of the road, and we acquired that property. We also worked with the Clayton County Emergency Management folks. They were the managers of the actual grant funds for CDBG. So we had to go through a subcontractor agreement so that we can use those funds for this project, and make sure that that was okay with the folks at the CDBG office. Next slide. So, we went to our board and we recommended moving forward with the task order for R2T to do the actual design work. We also had to authorize our board chair to execute the agreement with Clayton County government, because CCWA and Clayton County are different entities. So we had to create a subcontractor agreement, which is managed by the HUD office at Clayton County. We had to make sure that we had our funding available in our stormwater budget. We're still working on the actual design. We're actually in the process of preparing for the bid services. We'll select the contractor, and we will hopefully perform that work, get it all done here within the next 6 months or so. So that's our goal. We'll be putting that out to bid here shortly. I think that's the last slide.
Yeah, we'll pause here and do a poll question. So let me launch it real quick, but the poll question is, which item is not part of the engineer's design and bid phase scope of services on this project? Boundary survey and tree inventory, permitting, detailed design, channel dredging. So if you would like to receive 1 hour of CFM continuing education credit, be sure to answer the poll question. The question should appear as a pop-up on the screen, but if it doesn't, be sure to check the chat and there should be a poll functionality in there. So I'm just going to give everyone a few moments to review the question and answer, and then we'll move forward.
Aaron, I'm having a little bit of problem seeing that in the chat. The poll question in the chat.
I see it on my end. If you don't see it, then you can type your answer in the chat as others have done.
You may have to scroll up in the chat a little bit. I did it twice. I did it once in the chat and then scroll back up and found the button.
Yeah, some people have answered already, so might be a little further up than you anticipate.
Actually, my chat's not working.
Okay, I think we will close the chat up. We do have a lot to get to today. Close the poll up, excuse me. So 90% of people said the answer was channel dredging. Kevin, any last remarks before I move on?
No, channel dredging, that is correct. That's not part of the engineer's design or bid phase scope of service on this actual project.
All right, thank you. Next we'll move on to Robert Brown, whenever you're ready.
Thank you. Good afternoon. Look forward to talking about a project that I worked on recently here, just wrapped up the last couple of years ago, down in coastal Georgia, down in St. Mary's, with some green stormwater infrastructure. Next. So St. Mary's is located in Camden County, which is the southeasternmost coastal county within Georgia. Just want to give a little bit of background about this site and project. So down in coastal Georgia, we have very flat topography. This particular project was right in downtown St. Mary's and right on the St. Mary's River. They had a lack of overall drainage infrastructure, so there's a lot of street flooding during summer thunderstorms. There's also very narrow sidewalks, limited pedestrian facilities, and kind of you see wall-to-wall impervious surfaces. So a lot of stormwater runoff is generated from this site, and the city was looking to do a streetscape improvement, coupling that with stormwater upgrades. Next. So there's been a lot of planning efforts in St. Mary's that led to some additional grant funding that was received for this project. Through all the planning efforts, it helped identify that this was a priority area that needed stormwater improvement, so that provided some extra benefit during grant applications as we're looking to receive grant funding for some of the stormwater upgrades. A key plan was the St. Mary's 9-element watershed management plan that was completed in 2014. Because this area of the St. Mary's drains to the St. Mary's River where there's dissolved oxygen impairment, and because there's this 9-element watershed management plan, it enabled the city and the project to be eligible for Section 319H grant funding from Georgia EPD. So that was a benefit for having some of the planning taking place in the city. Some of the later plans just identified more that there was recommended stormwater improvements, and then once the streetscape project was conducted, that it was recommended to include green infrastructure practices. Next. So the overall goals of this project were enhancing those roadway and pedestrian access, as well as addressing the stormwater flooding that basically occurs after every intense rainfall event. By pursuing grant funding, the city was able to expand the footprint and not just do a couple of blocks on the St. Mary's Street on the southern end of that picture, but they're also able to run several blocks up Osborne Street, and then the green dot at the top of the picture is up at City Hall, so they're able to do additional green stormwater infrastructure implementation at that location as well. So they coupled Georgia or GDOT grant funds that was state funded with Georgia EPD Section 319H grant funds, which is federal funds, to utilize some match from the state funds for the federal grant, so that they were able to kind of generate more match without as much use of local funds. So it was a good combination of grants that were used at this site. Next. So overall, from the Section 319H grant, the city received $500,000 in grant funds because it was conducted in 2 phases, the St. Mary's Street on the riverfront, and then phase 2 being up by City Hall, improvements along Osborne Street up there. So the grant funds basically paid for the majority of the green infrastructure elements that were incorporated into this project. In total, there was 19,300 square feet of permeable pavement, and this is basically solid paver blocks, but there's small stone in between the blocks to allow for infiltration into the surface, and then a washed stone aggregate base layer below that to create storage for the stormwater runoff. And then there was 7,600 square feet of bioretention cells installed in each of the landscape islands, which bioretention cells, if you're unfamiliar with them, they're just basically shallow depressions with a sandy engineered fill media to help promote fast infiltration rates and water quality treatment. The grant also incorporated monitoring and outreach education components that were part of the project. Next. So here's a before and after look of St. Mary's Street before and after the streetscape improvements. You can see the much wider pedestrian usage, and then in that bottom picture, the bioretention cell landscape island present there. And the next slide, we have the system in action. So just after a rainfall event, before you had seen in some of those other pictures, the ponding up within the parking stalls. But now with the permeable pavement in place, all that stormwater runoff infiltrates into the permeable pavement system, all the parking stalls. And then the bioretention cells, you can see the shallow ponding of stormwater that started to pond up in those bioretention cells. So it just allows for storage of about 6 to 12 inches of runoff. It infiltrates into that gravel mulch and then into 1.5 feet of engineered soil media with a sandy content. And then you kind of see in this picture in the background as far as the St. Mary's River in the background right there. So that's a tidally influenced river water body, and I'll be discussing that a little bit later. Next slide. So I'd mentioned that the project incorporated some monitoring components as well. So I'm just going to highlight all the components, but really focus on the hydrologic elements of the monitoring. Next. So we installed 14 shallow wells across probably about 10 of the bioretention cells and permeable pavement systems so that we could monitor the performance of each of the individual systems. So within a well, we included a solvents level logger and had two different configurations. One was to measure the surface ponding and surface infiltration rates into the bioretention cells. But then we also had ones installed in slotted well screen that went down into the gravel layer or into the engineered bioretention media to measure the rise and fall of the water within the subsurface zones to look at overall storage and infiltration and exfiltration rates. We also had a tipping bucket rain gauge on site so that we could be measuring rainfall intensities and depths during each storm event so that we could model the runoff and inflow into each of the systems to use in our evaluation of the individual practices. Next. So here are a couple examples of those wells deployed in the phase 2 site up near City Hall. So on the left-hand side in our permeable pavement, we had a slotted well screen that went into the gravel storage layer below the permeable pavement to measure that exfiltration rate into the underlying soil and allow us to see when the subsurface storage was at capacity. On the right-hand side with the bioretention cells, we had 2 wells installed in each of the bioretention cells. The one was slotted in the surface zone, so we can measure the rise and fall of surface ponding, measure infiltration rates, and then the other was slotted in the underlying subsurface in the media layer, so we can measure the rise and fall of the water within the subsurface zone to measure exfiltration rate. And then both of those were used to evaluate to see when surface and subsurface layers were at their capacity and limits. Next. So overall, we had 1 year monitoring period for this site, and I'm just highlighting the permeable pavement well from the City Hall location. Quick explanation about this graph just before we get into some of the details. So on the right axis is rainfall depth, and that's the green line coming from the top in inches. And then on the left axis, this is water level depth in elevation in feet, coming from the bottom in the blue line. Anytime the blue line gets above the orange dashed line, this is the elevation of our bottom of our paver elevation. That was when our subsurface capacity was exceeded. So of these 71 events, only one completely filled the gravel storage layer and caused the subsurface capacity to be at its limits. And that was for an event that was just over an inch, but it was due to a very rapid intensity. We had an event later in the monitoring period that was 3.6 inches from Tropical Storm Elsa, and that one was fully infiltrated just because it was over a longer duration. In general, this site exfiltrated the whole subsurface storage zone within 12 hours or less, and we had similar conditions of the accumulation of water in the subsurface zone throughout this whole monitoring period, indicating that it was still infiltrating just as well at the end of the first year as it was in the beginning. So it did not have any effects from surface clogging, limiting its infiltration capacity into the surface. The next slide is looking at the bioretention over the same type of graphic as far as rainfall depth versus water level. Here, the water level in purple is just in the ponding zone. So once it got above the orange line, that's when it got to where there's an overflow grate to discharge runoff to the connecting stormwater system. But for any event that was below that dashed line, it was fully infiltrated because the system did not have an underdrain. So any water that was infiltrated through the soil media was exfiltrated into the surrounding and underlying soil. This cell, I would like to point out, it was quite a bit undersized, maybe about 1/3 to 1/2 of capacity because of limited space availability due to this retrofit design. But overall, from the 71 events, we only had 18 with overflow. Our smallest event with overflow was just under 1/2 inch, and that was due to a very rapid rainfall intensity. The largest to fully infiltrate without having any overflow was 1.4 inches. So if we have enough duration or lower rainfall intensity, much larger events are able to fully infiltrate it into the system. Our infiltration rates range from 1 to 3 inches per hour. The lower rates generally corresponded when there was more frequent periods of wet weather or cooler temperatures. Next slide. So I highlight a few of the examples of the great performance that we had at our phase 2 site up near City Hall. There's not enough time in this talk to go into the detail with everything that occurred at the riverfront site in phase 1. Primarily, we had some influences with tidal impacts on the stormwater outlet. So on that left side, or that picture, you see the stormwater outfall with the St. Mary's River kind of halfway inundating that pipe. The tides down in St. Mary's range from about 6 to 8 feet twice a day. So there's periods where water backs up into that stormwater pipe and then somewhat into the stormwater, into the underdrain system. So after the first month, based off our monitoring data that we're seeing, we had installed a inline tide control into the underdrain to help relieve and limit the amount of water backing up into our underdrain system and limiting our storage capacity in the system. So found it was quite helpful for most of the storm events, that was an effective tool for managing the tide. Next slide. And then we did have water quality monitoring, but there was limited data to draw some major conclusions just because of the faster infiltration rates. We had set up to monitor the flow from the underdrain, from the combined underdrain of permeable pavement and bioretention, but it was very tough to get samples from that because it would infiltrate within a couple of hours. That large storm event with 3.5 inches, it infiltrated within 12 hours. So it was challenging to get enough samples to draw major conclusions. And then also we had a few storm events where we had a pretty good first flush come off from the pavement and saw great concentration reductions, but the majority of the storm samples from runoff are relatively clean in terms of TSS and nutrients. So it's hard to clean water. So we weren't able to get too many good data points for that. But next, I just wanted to highlight a few conclusions from this study. So overall, the implementation of green infrastructure on the riverfront on St. Mary Street resulted in fewer instances of street flooding because we're able to have a lot of storage in those subsurface layers beneath the permeable pavement and bioretention cells. I know not everybody works on a coast where you're working in tidally influenced systems, but tidally influenced and high water tables have a lot of similarities, and you may experience or come across those more often with high water tables. But either of those two result in some reduced functionality because as the water table encroaches into the bottom of our infiltrating surface of a green infrastructure practice, it reduces the infiltration rate. And if it encroaches into that layer, then you reduce your storage capacity. We found some positive results using tide control for the tidally influenced systems. You see on this graphic to the left of the red dash line, this was before we had the tide control installed, but then afterwards, a much drastic reduction in our water level that we were measuring in our underdrain system. There was still some water getting its way into it, but it was much less than it was in the first month before that was installed. Next slide. And then from phase 2, site up near City Hall, before and after for our summer rainfall events, you can see the effect that was seen by the public that was coming into City Hall as far as not having to walk through that ponded water in the roadway and parking lot. But overall, this site had much sandier soils and deeper water table depths. So it was much more effective than the site down near the riverfront. So it's important if you're working on projects with either looking for retrofits for green infrastructure practices or doing a new development to try and utilize soil testing so that you can do some site fingerprinting to find where you can basically maximize your infiltration. So if you found a lot of sites like near City Hall where there's deeper water table and sandy soils, focusing your infiltrating practices in there to get more bang for your buck. And then lastly, with high water table one last thing on that slide. With high water table considerations, down in the coast, you come across high water tables more frequently. So permeable pavement is generally the practice that's installed more frequently than bioretention cells, kind of different from the rest of the US. Just because bioretention can be installed with a shallower profile, it really only needs about 1.5 feet or 2 foot. But a bioretention cell, by having the surface ponding, the media, and the underdrain layer, you're looking at 3 or 4 or 5 feet or more of depth that's required. The St. Mary's sites we had installed with 12 to 18 inches of soil media, where generally it's about 2 to 3 feet or sometimes 4 feet of media, just because we're trying to implement a practice that would be effective and still be infiltrating some, but not limit ourselves just because we didn't have the available depth to implement the system. And then on the last slide is just highlighting that these systems are very dynamic and that infiltration that occurs during an event, so intra-event infiltration, is just very important for green infrastructure functionality. So this is just an example of the permeable pavement system up by City Hall, where they had 1.7 inches over an 8-hour period. But because there was 2 to 3 hours in between each of the bursts of rainfall, it allowed that system to start to infiltrate and create more storage capacity so that this system was fully infiltrated, or the storm event was fully infiltrated, where if it was just if all the rainfall came as once, it probably would have only stored 1 to 1.2 inches of rainfall. And
we'll just take a quick pause here for another polling question. So let me launch that real quick. But the question is, which factors impact the function of green infrastructure practices? Water table depth, soil type of underlying/surrounding soils, tidal influence at stormwater outlet/outfall, or all of the above. And again, please answer the question using the pop-up. And if you don't see that, please check the chat and you may have to scroll up a little bit just to find it. But I'll give a few moments just to answer this and then we can review. All right, I'm going to go ahead and close the poll now. And the majority, if not all, said all of the above. So great job. And then did you have any closing remarks? If not,
Yeah. I just want to acknowledge the funding source for this grant project from the Georgia EPD Section 319 grant program. Thanks.
Well, thank you. And next we'll move on to Donovan, who's going to talk about his success story in DeKalb County. So whenever you're ready, I will allow you to share your screen.
Good afternoon. I will be discussing approaches to mapping and regulating drainage areas of 100 acres and more, future conditions floodplain, and FEMA SFHAs. And this is specific to the Metro Atlanta region. And so the foundation of this is in the ordinance that was adopted back in 2008 that defined the floodplain boundary in DeKalb County down to the 100 acres or greater basin. So we had to study the areas draining 100 acres or more per the ordinance and provide those studies for the engineering community. And so in addition to the FEMA SFHAs, DeKalb County applies the future conditions floodplain as well as the effective water surface elevations for areas draining 100 acres or more. In addition to that, in 2019, we were required to update our ordinance to regulate flood-prone boundary area. And in DeKalb County, it is identified as the area adjacent to future conditions floodplain. This area adjacent to future conditions floodplain is the higher of 3 feet above the base flood or 1 foot above the future conditions flood elevation, whichever is higher, unless the area is hydraulically independent. And so this is what we have an obligation to enforce. Here we have the DeKalb County parcel viewer, and the SFHAs, the local studied 100 acres areas, and the future conditions and the AFCF boundaries are available for constituents, engineers, anyone who is interested in looking at the parcel viewer and mapping and identifying whether or not there is flood risk at a particular property. So over on the right, there are layers that would communicate the different floodplain features. So you can enter an address, search for a particular property, and through this, you have a number of assets available for you to identify flood risk exposure. You'll notice there are these red anonymized areas. These are repetitive loss areas. These are areas where DeKalb County has historically found that there have been paid claims against the National Flood Insurance Program. The specific location of a claim is anonymized, but this indicates that if someone is in one of these areas, there is a risk based on historical data of repeated flood losses. There's a slight lag here. You can expand using the directional caret over here on the right to see symbology information. Here we look at the FEMA flood-prone boundary area. So for example, in this area, the symbology presented shows what areas are zone AE floodplain versus zone AE floodways versus zone AE floodplains, and the other flood hazards that might be identified in a FEMA map. So we have the symbology indicating that this shade of blue indicates that this is the 100-year or zone AE floodplain, as opposed to this darker blue area, and this is a local studied floodplain area. This is one of the basins draining to the FEMA floodplain that has established water surface elevations across this area. So properties within this area would be regulated through our permitting systems, and these properties would need to be elevated, and they are subject to substantial improvement standards and other regulations. It's indicated as the L100 areas. Additionally, there is if the local 100-acre plus area is disabled, you'll see that this is shown as green. This would be your 0.2% annual chance floodplain. So if someone was using the FEMA maps, the D firms would indicate that this is 500-year floodplain. That is why it is necessary, and it's recommended that anyone interested in identifying where there might be flood risk should use the DeKalb County Parcel Viewer. Otherwise, they would inaccurately determine or make an assumption that this is not regulated floodplain. This is in fact regulated floodplain in this area. Beyond that, we have the future condition floodplain. The water surface elevation for the future condition floodplain is available through resources available on the DeKalb County Parcel Viewer. Through supporting information, supporting data, you have cross sections that you can enable, and these cross sections show the named water body, the stream station, as well as the various storm events that are in the models for this particular basin. So the 2-year storm event, two-year water surface elevation, 5, 10, 25, 50, and 100-year, 200-year, 500-year, and the future conditions, water surface elevations are presented here. So you'll see here that the 100-year water surface elevation is at 857.2. In the effective and the future conditions for this area, the water surface elevation is 857.3. The information for base flood +3 is presented here because that is the basis for the area adjacent to future conditions floodplain. So we'll deselect this. This is the boundary for the area adjacent. So you would have you can see that there's a slight difference across this area between the local studied, which is the effective 100-year water surface elevation, and the area adjacent, which is at base flood +3. So this pale blue area indicates areas where, whether relative to the local studied areas or relative to the FEMA SFHAs, these are flood-prone boundary areas, and we do regulate lightly in these areas. We recommend that buildings, structures in these areas be elevated up depending on whether or not they are non-residential or residential to either the base flood +3 or future +1. And if it's for a non-residential, it would be, the structure would need to be elevated up to the base flood +1 or future conditions floodplain. Some information that is provided as supplemental, you do have the lettered and non-lettered cross sections indicated in the area. So you'd see that if you wanted to correlate between a FEMA DFIRM and the DeKalb County resource, you'd see that this is the location of a lettered cross section, and the named tributary, the stream station, is referenced, and you have other information here as well. Additionally, we have we provide access to the USGS rain gauges in the area so that someone could directly click on the US rain gauge, and it would, if you select the highlighted text right here, it would take you to the actual rain gauge and look at live and historical data available for that area. And so this is one approach to communicating flood risk exposure as presented by DeKalb County. And this is available for anyone to use if they're interested in redeveloping, or if they have general questions regarding floodplain, as well as more detailed information. So these are all available for constituents. Are there any questions?
I don't see any in the chat, but please, everyone, feel free to put questions in the chat so that we can ask our speakers more information that you're interested in. But Aaron, if you want to go ahead and launch our poll question.
Yes.
Mark asks, what are the red zones? Sorry, he missed that. Donovan, if you want to quickly just reiterate that.
The red zones are these are locations where we have data that there has been previous NFIP flood loss claims, and we cannot specifically identify the property where the claim occurred, but we can indicate that there is a history of flood losses within this area where claims were paid out through the National Flood Insurance Program.
Thank you. And let me take the share screen back. So I just have one last poll question. Again, please check the chat if it's not a pop-up on your screen, but the poll question is true or false. The name of the mapped flood-prone area in DeKalb County is AFCF, or area adjacent to future conditions floodplain. And I'll just give a few moments for people to respond. And in the meantime, if you're waiting, you already answered the question, feel free to drop any additional questions you have in the chat and we can address those momentarily. Looks like most people have responded, so I'm going to go ahead and close it up. And majority of people said true, and that's correct.
Fantastic. Well, I do have a question to each of our speakers. Just very quickly, what were some of the challenges you faced with outreach in your projects, whether that be internal customers or the external customers and general public? Kevin, Rob, Donovan, anyone want to start with that one?
Yeah, I'll go first. The couple of challenges we had were that with the green infrastructure stormwater management practices, the members from the city, as well as some of the council members, they weren't as familiar with those. So trying to get an explanation to them as far as what the function of them are and what they would look like. That was kind of a bit of a challenge to kind of like explain that stuff so that they could understand what we're installing, because it's a little different from the norm. So just getting that communication upfront about the benefits that it would be providing, and that it's a newer system or newer types of practices, but that it's more effective and efficient.
Thanks. Kevin?
Yeah, for us, obviously our challenge was because the problem was really private property. We're not necessarily responsible for doing maintenance activities on private properties, but as we went out there, especially after that storm came through in 2020, when the commissioner came out, they were able to really sort of help get the ball rolling because of the funding of it all. They were able to sort of help us, with the CDBG funds to at least get something moving forward so that um, uh, we can assist those folks on their private property areas there. And of course, dealing with the public over there, we've got several residents that continue to call us, all the time, wondering what the status is on the project, and not wanting to be left out of anything that's going on. So we try to stay in contact with the residents to let them know what stage we're in. As a matter of fact, I was recently asked to come to another meeting with those folks, even though they can call me directly and find out the status. I think they like to have the meetings with the commissioners there, and I think the commissioners like to have those meetings also. I'll leave it at that.
Sure. Donovan?
The outreach is getting people to use the resources and accepting the data in the resources. People have opinions about the flood mapping approaches, and some persons are typically reluctant to accept the data that, yes, the model does indicate that it is likely to flood in these areas.
Okay. If everyone would like to put their name and email in the chat that's interested in getting any continuing education credits, we're going to keep talking for just a few more minutes here. Donovan, we did have another question come in for you. How did you get those claims data?
from historical data that had been compiled years ago, and we mapped the areas and then anonymized the information. But it's available through FEMA Region 4.
Okay. All right. Thank you. I also just want to remind everyone, yes, Devin? Can we bring Devin off mic so he can ask his question?
Oh, thank you. Yeah, well, I was gonna say, I don't know if this is just me. It will not let me enter anything in the chat box for my email, but I did have
Okay.
another question for the presenters in terms of the 319 H grant funding. So it sounds like the Clayton County project is watershed management funds from the stormwater program, the utility and whatnot, and like HUD, and there was another acronym in there, and some from the county, and then with the project in St. Mary's, that was 319H. And I guess what I'm curious to know is, was I know with 319H grants that it's got to be something that's above and beyond your permit requirements, and I guess because you're technically improving existing facilities flood management, that's how that counted as above and beyond. I know that's a dumb question, but I'm just trying to wrap my head around when something qualifies and as above and beyond and can qualify for those kind of funds and when it can't.
So with St. Mary's, they were a unique situation because they're not a MS4 permitted community. So they were previously listed as an urban cluster, not an urbanized area. So they're not an MS4 permittee. So anything they were doing was going to qualify. But there's some other MS4s that I've worked with that are MS4 permitted communities, and a lot of the work that they're putting in, whether it's like a demonstration project or something else, it was listed that it was above and beyond their permit requirements because they were basically going in and retrofitting something that they weren't required to put in, but they wanted to do that to improve the water quality in their watershed.
That makes sense and confirms kind of what I was thinking. Thank you.
Yep.
And you had inquired about, I guess, CDBG, Community Development Block Grant. I believe the county government had a CDBG funds to do some sort of flooding improvement or flooding mitigation. It wasn't totally descript, but they wanted to use it for that purpose, and they were able to take some of those funds and apply towards this project. And on the stormwater side, we try to put some money from our stormwater fee. We try to budget funding on an annual basis to sort of apply a surplus of funds so that when watershed projects do come up, we have a funding source to pull that from.
Great, thank you. That's an interesting funding source and a cool project. I appreciate y'all sharing.
And Devin, and to anyone else, if your chat feature wasn't working, if you would send Erin Kyle an email just to let her know that you were trying to participate today, or you can send it to me at emily.wingo@dnr.ga.gov, or the email that you got for registration should have Erin's email in there as well. If you can send it to either one of us, and we'll try and get that straightened out. Meantime, everyone, thank you so much, gentlemen, for that very informative webinar. I know I enjoyed it immensely. We do have on the screen 2 QR codes. One is for our next Lunch and Learn, which will be held in January. Starting next year, our Lunch and Learns are going to move to the second Tuesday of every other month. So it'll be on January 8th. And also we have on the screen the
registration.
The registration, but the survey link as well. So if you can, please try and answer those survey questions for us, because it really helps us as we go forward with our next series of webinars. And with that, if anybody else has any second Wednesdays, yes. Did I not say second Wednesday, Bruce? I'm sorry. Second Wednesday starting next year, first one being on January 8th from 12 to 1. And if anyone else has any other questions, please feel free to put it in the chat. We're going to keep that open for a little bit longer and we'll get back to you. If you can throw your email in with your questions so that we can follow up with you, we appreciate that. A copy of the presentation will be emailed to all attendees. If you're looking for continuing education credits, those certificates will be emailed separately. Once more, Next Lunch and Learn scheduled for the January 8th, so please be sure to look out for that. And for those who don't have any other questions, this ends our Lunch and Learn webinar. Thanks, everyone, and have a great day.